100 meters beneath the surface of the Pacific Ocean, a heat anomaly so large it defies easy description is already moving. It has been building for years. It cannot be stopped. And the moment it breaks the surface, every country on Earth will feel it. The official index reads near neutral. The ocean surface looks calm, but the supercomputer models reading the deep data are projecting something that has senior forecasters genuinely alarmed. A super El Nino potentially stronger than anything in over 100 years. The heat is already in the water. The mechanism is already running. What comes next is not a forecast. It is a sequence that has already begun. By the end of this video, you're going to understand exactly what is happening beneath the Pacific right now, why the surface index is hiding the true scale of what is building, and why this specific event is categorically different from every El Nino in the modern record. You're going to understand the chain of consequences, not as a list of distant weather events, but as a single connected physical sequence that starts in one place and ends by making 2027 the hottest year ever recorded in human history. There is one piece of this that almost no mainstream coverage has addressed. It is the part that explains why the scientists studying this are not calling it a strong El Nino. They are calling it something else entirely. Stay with this. Start with the heat itself. Right now, 100 meters beneath the equatorial Pacific, a vast pool of water is running 5 to 6 degrees Celsius above normal. 5 to 6 degrees, not above the air temperature, above the normal ocean temperature at that depth. To understand why that number matters, you have to understand what the subsurface Pacific actually does. The equatorial Pacific is not a passive body of water. It is an engine. It stores heat on one side, releases it on the other, and the trade winds are the mechanism that keeps the system balanced. Under normal conditions, the trade winds blow east to west across the Pacific. They push warm surface water toward Asia and Australia, piling it up in the western Pacific like water against a dam. That warm pile is real. It is physically measurable. On the other side, the eastern Pacific off the coast of South America, cold water rises from the deep to replace what the winds push away. That cold upwelling keeps sea surface temperatures low. It keeps the tropical heat engine in check. It supports one of the most productive fisheries on the planet. When the trade winds weaken, the dam breaks. The warm water that has been piling up in the west begins moving east, not across the surface, through the body of the ocean itself, as an invisible underwater wave called a Kelvin wave. That wave is already moving. Scientists have been tracking it for months. It is carrying 5 to 6 degrees of excess heat eastward through the ocean interior, invisible to the surface, invisible to the official index, and completely unstoppable once it begins. Here is what the official index is not telling you. And this is the detail that separates this event from every other El Nino discussion you have seen. The standard El Nino index measures sea surface temperatures in a box in the Central Pacific, called the Niño 3.4 region. When the subsurface Kelvin wave has not yet reached the surface, that index reads near neutral. The surface looks calm. The models, looking at the subsurface data, see something entirely different. And right now, the surface and the subsurface are telling completely different stories. The last two major El Nino events were in 1997 and 2015. Both caused global catastrophe. The 2015 event peaked at 2.75 degrees above normal, drove a global temperature record, caused catastrophic coral bleaching across the tropics, and disrupted growing seasons on multiple continents. Current deep ocean measurements suggest this event could climb past 3 degrees. Past 2015, past 1997, past every El Nino in the entire modern instrumental record. Potentially the strongest since before the invention of the automobile. That is not a dramatic headline. That is what the subsurface data shows. And there is a specific reason this event has reached this scale that almost nobody is talking about. Stay past the 4-minute mark. Because the mechanism behind the size of what is building is the part that changes everything. The reason this heat pool is so large traces back years, not months. Solar cycle 25 has been running hotter than predicted. The Pacific Ocean has been accumulating excess heat for years without a significant release event. The warm water in the western Pacific has been building and building and building. Think of it like a compressed spring. Every year without a significant El Nino is another turn of the compression. The 1990s gave us strong releases. The 2000s and 2010s were quieter. The heat kept accumulating in the western warm pool, waiting. When the trade winds finally weakened, which they have measurably over the past several months, they released a spring that has been compressing for years. The Kelvin wave now moving east is not carrying one season of excess heat. It is carrying years of it. That is why the subsurface anomaly reads 5 to 6 degrees instead of 2 or 3. That is why the supercomputer models are projecting past 3 degrees at peak. The system has been loading this event for a long time. Now, here is the first open loop closing, the one about why scientists are not calling this a strong El Nino. The threshold for what the climate community considers a super El Nino is not officially defined by a single number, but the working definition used in most research is a sustained peak anomaly above 2.5 degrees Celsius. 1997 peaked at 2.3. 2015 peaked at 2.75. Both are considered borderline super events. A sustained anomaly above 3 degrees would be, by every research definition currently in use, unprecedented in the modern record. That is the target the subsurface data is pointing at. Not confirmed, not guaranteed, but the heat required to reach it is already in the water, already moving, and there's no physical mechanism available to remove it before it surfaces. Here's what happens when it does. The cold upwelling off the coast of South America shuts down. The thermocline, the boundary between warm surface water and cold deep water, drops. The cold water that normally rises to the surface can no longer reach it. Sea surface temperatures in the eastern equatorial Pacific spike. The temperature gradient across the entire Pacific flattens. The atmospheric circulation that depends on that gradient, the Walker circulation, collapses. When the Walker circulation collapses, the atmospheric consequences are not regional. They are global. The jet streams reorganize. The monsoon systems shift. The rainfall patterns that billions of people depend on move, sometimes by thousands of kilometers. And they do not move gently. Here is where this becomes concrete. Here is the sequence of consequences that this specific event is projected to trigger, not as independent weather events, but as a single connected chain. The eastern Pacific warms. The Peruvian coast, normally cooled by upwelling, floods. The rains that the Atacama Desert receives once a decade arrive all at once. The infrastructure built for a desert is not built for floods. This happens within months of the event peaking. Simultaneously, and this is the counterintuitive part, the Amazon rainforest goes into drought. The atmospheric moisture that normally flows from the Atlantic into the Amazon basin follows the Walker circulation. When that circulation shifts, the moisture follows it. The Amazon drought of 2015 to 2016, driven by the last major El Nino, was the most severe in recorded history at that point. Fire activity across the Amazon tripled. Carbon emissions from the forest itself spiked. A forest that normally absorbs carbon became a carbon source. Current projections for a super event suggest the 2015 Amazon drought was a preview. The same mechanism, running harder, produces the same outcome at larger scale. The forest does not have time to recover between events at this intensity. Australia faces a different version of the same problem. El Nino events suppress rainfall across eastern Australia by shifting the convergence zone that drives Australian monsoons northward. The correlation between El Nino intensity and Australian drought is one of the strongest climate teleconnections on the planet. The 1997 to 1998 event was followed by catastrophic bushfires across eastern Australia. The 2015 event preceded the 2019 to 2020 Black Summer, the worst fire season in Australian recorded history, burning over 18 million hectares. A super event at this projected intensity places the eastern half of Australia under drought and extreme wildfire risk simultaneously, not as a worst-case projection. It has the expected baseline outcome based on the mechanism already in motion. By the way, and this is the detail that rewards people who have stayed this far, the Atlantic hurricane season during an El Nino year is typically suppressed. But suppressed does not mean quiet. It means fewer storms forming, but the storms that do form develop differently. During El Nino years, the Atlantic experiences increased vertical wind shear in the main development region. That shear inhibits tropical storm formation in the open Atlantic, but it does not inhibit formation closer to shore. The storms that do develop tend to form in the Gulf of Mexico and the Western Caribbean, dangerously close to populated coastlines with almost no warning time. The 1997 Atlantic season produced only 8 named storms. But one of them, Pauline, struck the Mexican coast with catastrophic force, killing over 200 people. A quiet season statistically is not a safe season geographically. Here is the piece of evidence that reframes the entire global picture, the one that the first half of this video was building toward. Global average temperature in 2023 was already 0.17 degrees Celsius above the previous annual record. That record was set without a significant El Nino. It was set during a La Niña to neutral transition, a period when the Pacific was actually suppressing global temperatures slightly. The record was broken anyway. El Nino events add heat to the global average because the warm Pacific exports enormous quantities of energy directly into the atmosphere. The 2015 to 2016 event added approximately 0.2 degrees Celsius to the global average temperature in the year it peaked. If this event peaks past 3 degrees, as the subsurface data suggests it could, the addition to the global average is not capped at 0.2. The relationship between El Nino peak intensity and global temperature addition is not linear. At higher intensities, the ocean vents more heat more rapidly. Conservative projections from the modeling groups tracking this event suggest a global temperature addition of 0.25 to 0.35 degrees Celsius in the peak year. Add that to the 2023 baseline, itself a record, and 2027 becomes mathematically the hottest year in the entire human instrumental record. Not by a small margin, by a margin that would rewrite every country's climate baseline simultaneously, every drought threshold, every flood frequency table, every heat mortality projection, every agricultural yield model, all of them recalibrated to a new normal, set by a single year. The California atmospheric river pattern is part of this same mechanism. During El Nino winters, the jet stream across the North Pacific shifts southward. It channels moisture from the subtropical Pacific directly into California in the form of atmospheric rivers, narrow corridors of concentrated water vapor that dump extreme rainfall in short windows. The 2015 to 2016 winter produced the strongest atmospheric river sequence California had seen in decades. Mudslides in the coastal mountains, flooding in the Central Valley. The same pattern at higher intensity means the same consequences, amplified. Everything described in this video traces back to one physical fact that was established at the beginning. A subsurface heat anomaly 5 to 6 degrees above normal, already moving east through the Pacific, invisible to the surface index, unstoppable. The open loop from the beginning, why scientists are calling this something different, closes here. The term appearing in internal forecast discussions is not strong El Nino, it is super El Nino. That term carries a specific implication. It means the event exceeds every comparable event in the modern record. It means the global consequences exceed everything the historical record can be used to predict. It means the damage functions, the agricultural loss models, the flood frequency curves, none of them were calibrated for this. The 1997 event caused an estimated $45 billion in global damage. The 2015 event caused over $60 billion. The damage scaling is not linear with event intensity. It is exponential, because infrastructure fails at thresholds, not gradually. A transformer rated to handle a certain load does not degrade slowly as the load increases. It handles the load, handles the load, handles the load, and then fails completely. Agricultural systems work the same way. A drought 20% worse than the historical worst does not cause 20% more crop failure. It causes total crop failure in regions that were already at the margin. The regions at the margin for this event include the Horn of Africa, which is already in multi-year drought, Southern Asia, where monsoon failure following a strong El Nino has historically produced the worst food security crises on record, and the American Corn Belt, which experienced significant heat stress in 2023 without any El Nino forcing at all. The cascade is not a possibility. The cascade is what happens when the physics runs. The heat is in the water. The Kelvin wave is moving. The trade winds have already weakened. Every part of the mechanism that requires a trigger has already been triggered. What has not yet happened, what is still in the future, is the surface expression. The moment the subsurface heat reaches the surface of the eastern Pacific, the atmospheric response begins. That moment is measurable, being tracked, and based on the speed of the Kelvin wave already in transit, it is months away, not years. Here is the sentence that closes every loop opened in this video. The worst case scenario is not a super El Nino in isolation. The worst case scenario is a super El Nino landing on a global system that has spent 3 years running hotter than any previous baseline, with no recovery period, no time for soil moisture to rebuild, no time for ecosystems already stressed by previous events to stabilize. That is not a theoretical scenario. That is the current condition of the system into which this event is about to arrive. The heat is already in the water. The models are already running. The sequence is already in motion. 2027 will be defined by what is happening beneath the Pacific surface right now. 5 to 6 degrees above normal, moving east, invisible to the index that most headlines are still reading as near neutral. The world is not waiting for this event to begin, it has already begun. The surface just has not caught up yet. If this video changed the way you understand what El Nino actually means, not as a weather pattern, but as a global physical system with a sequence and a timeline, share it. The people who need to understand this are not only the ones already watching climate channels, they are the ones who do not yet know the heat is already in the water. Subscribe if you want to understand the next signal before the headlines notice it.